Hey, Math 7. Happy Friday. Today we're going to talk about learning how to solve percent change and percent error problems. So this is about how wrong are you? How close were you to the difference? Or what was the percent of increase and percent of decrease? Percent of increase and decrease, you can also use that to find tip, and you can use it to find sales tax percentages if you have the values but you need the percent. So two equations or setups that we're going to use. We have the percent of change. We take the amount of change by subtracting them, and then we divide it by the original amount, what you started with. That will give us a percent increase if it's going up, a percent decrease if it's going down. Percent error is the percent that an estimated quantity differs from the actual amount. So we're going to take the amount of error, like the total difference, and then we're going to divide that by the actual amount, or I'm going to add one more thing here. I'm going to say what it should be. Because you want to find the percent error, like if you're cutting something that's supposed to be 5 meters long and you cut it 5.5 meters long, you want to divide it by the actual amount it should have been. Okay, so you can find out how wrong you were. All right, so percent increase. The original quantity is 10 and the new quantity is 13. What is the percent of change? So I'm going to take 13 minus 10. I'm going to divide that by the original amount. So original is 10. So 13 minus 10 is 3/10. So 3/10, 3 divided by 10 would be 0.3, which is 30%. And that is an increase. The second one, Carl bought an airline ticket. 2 weeks ago, the cost of the flight was $300. Now it is $375. What is the percent of change? So let's take 375 minus 300. And then the original price was 300, so we'll divide by 300. So that gives me 75 divided by 300. So let's punch that in. You can do it too. So I got 0.25, which is 25% increase. Percent decrease, I'm going to follow the same thing. I just have to note that it's decreasing. So last year our website had 40,000 visitors, and this year it has 37,000 visitors. What is the percent of change in the number of visitors to the website from last year to this year? So we had 40,000 minus 37,000. And that is a difference of 3,000. And originally we had 40. So 3,000 divided by 40,000. There it goes. Okay. So 3,000 divided by 40,000. I got 0.075, which would be 7.5% decrease. All right, the next one. The original quantity is 5 and the new quantity is 3. What is the percent of change? So 5 minus 3 divided by the original amount. So that gives me 2 over 5, which 2/5 is 4/10, 0.4. So make that a percent. 40% decrease. So percent increase and decrease, difference of the values divided by the original, make it a percent, and you should say increase or decrease. All right, percent error. Sean estimated that the attendance at a college lacrosse game was 3,000. The actual attendance was 3,296. What is the percent error of Sean's estimate? Round to the nearest whole. So we want the difference between the two, 3,296 minus 3,000. And this is where we need to figure out the actual versus should be. So we know it should have been, the real amount was 3,296. So we're going to divide that 296 by 3,296. Because we want to find out how far off our estimate was, or Sean's estimate was. 3,296. All right. I got 0.0898. And then it keeps going. If I make that a percent, I get 8.98%. So that is going to round to 9%. The specification for a length of a bolt is 4.75. A machinist makes a bolt that is 4.769 inches long. What is the percent error? So first of all, we're going to need the difference. So the difference is going to be 0. Let's see. 0.19. Oh, 0.019. That's a very slight difference. But in a bolt, it probably makes a difference. And then for the bottom, we want what the actual should be. We want what it should be. So if the specification is 4.75, we need to see how far it is off of the spec. So I'm going to do 0.019 divided by 4.75, and I get 0.004, which, let's make that a percent. Swoop it twice. 0.4%. All right, next question. What is the percent of change in the price of a gallon of gas if it goes from 3.499 to 3.099 or 3.079? Yeah, gas is one of those weird things. They add in that extra decimal place because it rounds up and people don't think about it. So we want to find the percent of change, the nearest whole percent. So we need the difference, 3.499 minus 3.079 and I got a difference of 0.42. Originally, it was $3.49, and there we go. So we're going to divide. Okay, I got 0.1200. So that will be a 12%, and it went down. So that would be a decrease. Craig likes to collect vinyl records. Last year he had 10 records in his collection. Now he has 12. What is the percent change? So 12 minus 10, and he started off with 10. So that's 2 out of 10. So 20%. And since he had 10 and now he has 12, that's going up. So increase. 20% increase. Rihanna has a container with a volume of 1.5 liters. She estimates the volume to be 2.1. What is the percent error? So we need the difference. 2.1 minus 1.5 would be 0.6 difference. And then the actual is 1.5. So 0.6 divided by 1.5, I got 0.4. So that would be 40% error. That's kind of a big error. All right, several students measured a 25 millimeter long nail and wrote the measurements in the table provided. Whose measurements had the greatest percent error? Round to the nearest percent. That's not your bell. Haha. All right, so the difference is we start at 25. So we're going to have Lane has a difference of 1 out of 25. Tanisha had 25 minus 2, 23 is 2 out of 25. And then Juan had 25 minus 25, 0 out of 25. Thank you, Juan, for making it easy. He has a 0% error. So 1/25 would be 4%. Tanisha would be 8%. I'm just making those into fractions over 100 to make it easy. So who had the greatest percent error? Well, let's see. That would be Tanisha. All right. Have a great weekend. Refer back to these notes, refer back to the formulas that we started with as you're working through your problems.